Well, hi, good morning, and thanks so much for joining me here in my shop and keeping me company while I start on another project. It's September 15th. The Ides of September have come. Now, the last project I was working on, if you're watching my videos as I post them, then that project has been set aside while some light bulbs come. Get it back on my bench in a week or so or something like that and carry on with it. In the meantime, I'm starting on the next project. And my goal today is to simply assess this radio in terms of what it might require to repair it. My belief is it's in really good shape, and it may even be partially working. I can't remember what the owner told me now, but we'll find all this out as we start working on it. So this is a fantastic, great big tabletop. I mean, it's gigantic to go on top of the table. Grundig radio, and it's called a 3D Klang. K-L-A-N-G. A Klang. Now, that's not a very good name in North America for a radio. But that's what it's called. And it's got up here 2030. Well, it almost is 2030. 2030, 8 more years to go. Maybe that's its. That's probably its use before date, 2030. Well, that looks English, but it's just a number and a letter. Grundig. Uh-oh, it's all in German. This is the Sendersteinung, and this is the Laudenstark. I apologize if you're German and I'm upsetting you with my attempt to sound German. But that's it. So, lovely big white ivory looking keys. Beautiful dial with all kinds of writing on it. And cities we've never heard of, like Sotens. I think I've heard of Sotens. Bermunster. I think I've heard of that. Rias, Berlin. Rias-Berlin. Lots of interesting stuff on here. Rom. Obviously this isn't written in English, so Rom must be Rome. Okay. A couple of controls here. A couple here. Is this one knob? This is one knob. This is one knob. So I am turning the dial. It doesn't feel right. It feels like it's at the end. Where's the pointer? Oh, something funny going on. Can only turn it in one direction. Can't turn it back. Okay, the issue there has a magic eye sitting up here, which is kind of a cool feature. This guy was probably built, I'm going to guess, and it's just a guess, after the Second World War, but I'm not sure at all when it was built. What do we got in the back here? Well, that looks English. It's all in German. I'm very quiet. I can't read German. Here's the tube line up here. Let's see. EF89, EF89, EABC80, EL84, all very common tubes. And EC92, probably the FM tube. Well, there's an EM85. EM85. So maybe this is the magic eye. I don't know. I think an EM. Yeah, I can't remember. Oh, ECC85 is the FM tube. This is probably the eye in the front, and this is probably the FM tube I'm not familiar with. EC92. It's a built-in FM antenna. Probably just a aluminum strip inside the cabinet here. Loudspeaker. Serial number. Tonabomner. I'm going to guess this is the Tonabomner. Tonabegaro. I don't know what I'm saying. And there's some secret writing down here, which I cannot decipher. No secret writing coming through. Looks like it has speakers on the side, but sometimes these are fake. sometimes not. Okay, we can take the back off and look inside. Will I be operating this radio today? Possibly. It's possible. Pull it out. These are over tightened here. Something terrible. They're really, really cranked down. They don't need to be that tight. You just need to stop them from dropping. And these have been tightened right up. And so it's distorted the shape of the cardboard here. That's what's happened. Not a big crime. Okay, it comes out. There you have it. One dusty radio there. Any information's on the back. Nothing on the inside. Okay, let us assess. What do we got here? More light for my sake. Well, this is an FM receiver. Was it really an FM receiver? I can see the FM tuning plates and the tuning capacitor. I think the owner did mention that it has FM. Long wave, medium wave, canal, and UKW. UKW, I think, is the in megahertz, 189. Like a lot of European radios, they're designed so they're more based on wavelength than frequency. So in North America, you go from low frequency to high frequency, but in the case of these radios, it goes the other way. So the higher frequencies are at this end. So 189. So the modern FM range in North America is 108. It goes higher. And this starts at 88, goes to 87. So it's just missing the top part here. No listening to Q107 on this radio. But here where I live, there's some interesting FM stations around between 900 and between 90 and 100. So this would be fine in my area. Making an older FM radio work well is definitely challenging. No question about it. So we have, looks like a 3-bander. On off, a TA, a TB. I think that's what we saw on the back. I think that's probably tape and record. Maybe not tape, because did they have tape back then? Back at this time? Were there people with tape recorders? Long wave, medium wave. Where's the short wave? A UKW. Well, so long wave. So the long wave frequencies are 100 kilohertz up to 150 kilohertz. It's definitely long wave. Something that there's really nothing there these days but tons of noise. So you go lower down in frequency, the amount of noise in our homes goes up and up and up. In the AM band, it's practically overwhelming already. So here we have kilohertz, 510 to 1600. Broadcast, like AM broadcast band. Canal, it seems to be pointing to this area here, what has a kind of a funny step pattern. You can see it in the camera as numbers: 5, 10, 15, 20, 40. So I think this is for tracking and making a notation as to where you're picking up a station. But what am I missing here? Isn't this a shortwave radio too? Let me change cameras so we can get right up close to it and figure out what's happening here. Kilohertz? It says kilohertz. Would all these stations, all these names, be in the AM band? These are all short wave. This is what a short wave radio looks like. What am I missing? Well, I don't think this has shortwave. I think it has long wave, AM radio, medium wave, and that's what all these cities are related to. Can't say I've ever seen that before. It's always been shortwave that has this kind of presentation here. What's that? Graz Doble. And then down here is the FM band, and then there's the buttons. DA, MW. There's no shortwave band on here. I can't believe it. I keep staring at it until I find it. I don't think there is one. The 3D must mean 3 bands. And there they are. Long wave, medium wave, and FM. So the key thing in this radio to make it interesting to use is to get that FM band working. That's clearly where we got to go. It's practically true for all radios today, because who's listening to AM radio? Anyway, who is that? Who is it who listens to AM radio? Somebody, because goodness knows there's thousands of AM radio stations. Somebody's listening. Well, the long wave, there's really nothing there to receive. The AM, of course, there's AM broadcast stuff to receive. FM, okay, I think I've beat that to death. I have to get these things fairly straight. You know what we should do? We should look underneath this radio. Let's look underneath it. This radio is not as heavy as you might imagine. So, unlike many of these radios, there is no plate to remove here. A lot of these style radios, when you look at the bottom, there's a plate you can take off. Often it's a grill to let some air in, and then you can get access to a lot of the parts in the radio without ever taking the chassis out. These great big feet. Very good. And there's the screws that are holding the chassis. And now what is this? It looks like a gear selector. Well, you know what? There's something in there. Well, let's take a look and just see what we're looking at here. What are we looking at? It looks like a couple of adjustments, and it looks like alignment things that would be done, and you would do it with the radio back in the cabinet. But these are all waxed up. You can see that there's wax poured into the little cups there. Waxed up. Waxed up, not the best thing. Not the best thing. Okay, let's flip it back up. Yeah, I would expect this to be a lot heavier than it is. Maybe it's because it doesn't receive shortwave. You know, shortwave circuits, very heavy. Okay, let's take a look inside here. See what we got happening. Pretty interesting power cord, nicely done. Done correctly, the wires are done correctly. This is a replacement, I'm pretty sure, from a long time ago though. Tight. Wires in excellent shape, it's totally flexible. So this wire is clamped in down here in such a way that it would look to me to be original. Really nice piece of original. So maybe this is original. Cool looking. Yeah, some fuses here. This is probably how the radio is set for the voltage it's going to be plugged into. So here in North America it's 115, 120 volts, but in Europe it's twice that. So you probably just move the fuse to another location and then you can run it in. And there's 1, 2, 3, 4 possible places. Is there a hint on this? On the no. Ooh, maybe there is here. This would be the hint here. 110, 125, 160, 220, 160. It's made for a 50 cycle, but we have 60 cycle power here. That's okay. If you go up in frequency, it helps the transformer a bit. It will run slightly cooler. So putting 60 in here instead of 50, not a problem. There we can see that one a tube that was shown in the diagram on its side, and it's right in the FM tuning box. In here is all the tuning components contained in a box, because FM is such a high frequency, it needs to be cared for a lot more and protected a lot more. These holes are where you put a tool through to make adjustments to tune it up. Likewise, so these holes are the same thing. And there's going to be other adjustments here and there in the radio, some of them accessible from underneath. I see 2 light bulbs up there. I do see speakers on the sides. But these are not electrostatic speakers. In many of these radios, the tweeters are electrostatic speakers. And you have to, well, you got to be a little more careful with them. These are just your regular magnetic speakers. It says original Grundig multi, what? Original Grundig multi-dash. Okay, wait a second. I like to be curious of this. You know, when you're initially looking at a radio, it's a matter of how much time you spend looking at it that will determine how much stuff you spot. So I don't mind looking at things like this, putting in some time. Original Grundig multi. Well, it looks like OKTAV. Multi-octave. Multi-octave. Well, that's not much of a claim, I'm afraid. Walter Sprecher. Once again, somebody should kick me. Let's tune the radio and see what happens here. So this is moving. The string there. Look at the string. So what's happened here, I'm pretty sure, is the string is a cloth-covered cord wire. Looks like a wire with a cloth cover, and the cloth cover is slipped. That's what it looks like. So when I turn the dial one way, this is a little hard to perceive, but in one direction, the string wrapping loosens a little bit. The other direction, it's pulled tighter and it locks, which is why it's doing what it's doing. We best not force that. The string is intact, but looks like it's in trouble. You can see the string up here. That side has a wire. That's the sliding pointer. It's not sliding anywhere right now. On a wire, on a steel wire. Cloth going one direction. That's quite common too in these radios. They have steel in one direction and string in the other. There's the steel wire coming back and wrapping around the. This is the tuning capacitor. When you turn the dial, this should move. And move one bit. Let's see if it's stuck. Let's see if I can move it. Some of these old radios, this part can be stuck so tight it cannot be recovered. It cannot be moved again. Well, I can't move it. Take a closer look at this. Now, these are a kind of problem which can wreck a radio like this if this can't be made to move. So it may be stuck simply because I'm not moving the string and it's all just tight enough I can't move it. Or I think what's really happened is it's fused in place from dried lubrication or something like that. Can't move this, can't tune the radio. So we'll have to deal with that very early on. One of the things I do when I start on these radios is I'm asking myself, what is in here that's going to prevent the repair of this radio? Totally prevent it. And then normally the answer is there's nothing. There's nothing in these radios that you can't fix. Although some things are certainly harder than other things. But there are a few things that it becomes absurd to go ahead and fix. There's a resistor right up there on top of the magic eye, I think. Here's the antenna. let's just trace the FM antenna, because engineers do fancy things with these. So at this point, it's connected to these aluminum sheets, which are running in the roof of the radio cabinet. But that's not enough. It then carries on. So they have the two wires in a flat ribbon type cable. When it gets to this point, the two wires are tied together, go through a resistor. And well, what all is that? Coils, and then more wire, and more wire. It's a speaker. Oh, I must have slipped up in my tracing of wires. And the other one must be the other speaker wire. Well, that's a pretty weird situation there. It looks like the antenna is hooked up to the speakers. Maybe it's finding a ground over here. This is a ground terminal, and it's just utilizing a ground terminal that's coming up with the speaker leads. Those coils, they could be related to the speakers. They are tied up to these connections. I would say it's probably part of like a crossover sort of deal. Those coils would choke off high frequencies. Maybe the feed to the speaker goes through these coils in order that only the treble sounds reach these littler speakers. If you look at the output transformer here, great big thing on top, looks like a capacitor, but I'm not sure what that is up on top there. No signs of overheating or anything terrible like that. This is one of the components that if this has a fault in it, again, not very likely, but if it does, that's kind of the end of the radio. You have to get another radio virtually identical to this, or you're into jury rigging and finding some similar transformer. Good luck on that. And similar probably won't be good enough, because these things are playing a big role with the tone in the radio. These in combination with the speakers and other factors. There's this plate here, not so the output tube can examine itself in a mirror, but it must be for some reason. It has to be either one of two reasons. Heat, it's a heat reflector, or it's trying to contain or block radio waves. It's a fat chance on that. If it were doing that, it would be up close to the tube, maybe even a curved sleeve go right over the tube to catch electromagnetic waves. So this must be a heat deflector, I guess. So the output tube here, these tubes get very hot. The output tube gets very hot. There's no rectifier tube in here. Somewhere in this radio is a selenium rectifier, a solid state selenium rectifier, usually tucked around the edge and somewhere. You have to take the chassis out to find it. Now let's look at that question. There are 4 screws on the bottom. What all is coming out? So the speakers are not coming out. The speakers are bolted into the cabinet. The speaker wire is very short. Yeah, so we've got one wire. So we've got one speaker. I'll have to photograph this stuff before I fiddle with it. The one speaker's hooked here, and the treble speakers are hooked up over here. And they have in common the center pin, and there's a black wire going over top of this thing. Well, who knows why they do things exactly the way they do them. This looks like tape intended to hold the tubes in. I've never seen that before. Tape is missing here. So I wonder if this tube got replaced. This one's original because you can see, well, I don't know. Probably original because the tape is on it. Tape is on this one. Yeah, there's tape on that one too. Look, there's tape here, but my God, putting tape on this tube is so hot it would like practically burn the tape. This is, there's a good chance this tube needs to be replaced. This is the tube that wears out in these radios, and it doesn't look quite right to me. And I don't want to say too much, but up in here, this color you can see through the tube. It doesn't look quite right. But anyway, that's just an observation of really no value. What else can we see? There's some springs down here, probably involved with the, well, one's a spring and the other's a coil. But I bet you if I push one of those buttons, that spring will get stretched down. Well, buttons work nice. I didn't try them before. Ooh, that's the on-off. Okay, these radios kind of have trouble with the on-off switch. This one doesn't, it sounds like it's clicking in. When I take my finger off, a moment later it does that. So it could be the on-off switch is stuck on or stuck off. Okay, what's this blue? So this one is going up to this, to the magic eye tube. Eye tube is in a socket held by this spring, and you can see the paper has darkened where it's hot. I think probably the best thing to do is to leave the tube connected and try to get it off here and leave it on the blue wire. When I take out the chassis, probably the best thing to do here is unsolder all these wires, these brown wires, and leave the speakers behind. I'll use temporary speakers while I'm working on the radio. Put the cabinet away so I don't scratch it all up. If you notice the FM antenna sheet, this sheet of aluminum here, doesn't end. It goes right past the speaker and comes out the bottom here. So what did they do? They cut a hole in it where the speaker is? They must have. It's a pretty crazy arrangement. Mr. 447. And there it is. These screws, but most of these screws are coming through and holding the, there they are right there. There's the screw right there. Okay, now I don't think there's any reason to take any of that apart. Okay, that's the plan to remove the radio from the chassis. I'm going to have a little break now. Drink some coffee so my muscle strength is up. Come back, take the chassis out, and we'll look underneath it. And then we'll have seen the whole thing. Okay, screws are out of the bottom. I'm going to cut these wires free here, but I'm going to put a black mark on these two. They're the wires that go to the center terminal. And I think I can remember that the tweeters are on the right. Famous last words, I can remember that. So what I'm going to do, don't have it with me. I'm going to take a photograph of that arrangement. You know what, I can do it. I can do it using the video system right here. Let's just do it. So what I need to do, go like that. Just bear with me a moment. I'm going to snap a photograph right here. There we are. Photograph taken. Good. Those away. So the thing about the speakers, you're not going to see much looking at that. Come on. That's better. These speakers have to be connected in such a way that all their cones are going in the same direction at the same time. So we don't get this thing happening. If you get this thing happening, generally what you end up with is loss of bass. Generally. There we go. And the last thing is we need to free up the magic eye here. How have they done the spring? Let's go back to that other camera and we'll take a close look at the spring. The spring may be kind of not meant to be taken off. Looks like it's simply hooked there, doesn't it? Can I just unhook it? Not with one hand. Alright, just leave it here and just pull the tube out. No, the tube is kind of sunken into the cabinet here. Let's see if I can hook the end of the spring. There we go. Oops. Nothing holding that at all. Out it comes. Okay, I think it's going to have to remain kind of airborne here for now. What I'm going to do is I'm going to take it out of the socket so we don't have this thing flopping around. It's your magic eye tube there. EM85. Okay. It's ready to come out now. Now, once in a while there's a few other things that get caught doing this. And we don't want that to happen. Often has to do with the dial, but I'm pretty sure the dial, everything's going to come out. Make some space for this. To lift it out, the thing I do anyway, so I try to get control over the heavy weight of the transformer. So I usually just grab the transformer itself. It's not moving. Wow. Is there more screws? Wow, it's in there as solid as can be. How can this be? How can this be? What could be holding it? Now, bearing in mind the screws are out, maybe it's going to fall out if I'm not careful. I don't see anything else holding it in there. You know what? It's just stuck. It's just stuck so solid. Oh, what do you want? Hello? Yeah, that's all it is. Just stuck. Stuck on the rubber pieces. Yes, Peanut, you know what? Maybe in a couple minutes I'll pay some attention to you. What do you say to that? Oh, it's still stuck. There we go. Okay, unstuck everywhere. Unstuck everywhere. Out you come. Okay, we got it out. Let's take a look in the cabinet before I make it disappear. Got lots of numbers written on it. 459. There's an aluminum sheet here, and notice the copper technique they've used here to make a connection. They put a copper band around the rubber piece. You tighten the screw up from below, pulls the cabinet down, pushes on it, pushes on the copper onto the aluminum. Not much of a connection, really. Often there's something better done. Aluminum's hard to solder to, but usually there's a better arrangement here. Usually a little wire coming out or something like that. Not a big deal. Number 6 took a look at this. Or I can't read that. Probably some German thing. Okay. Any news in taking this out? No. I think no, nothing happened to it while we took it out. Yeah. Okay. Well, the next part of the story is underneath. Now, can we flip it right over? We flip it over, it sits on this, and sit on this, and be kind of unstable. This can probably take it, as long as I don't do any monkey business with it. The alternative is to stand it up on its end, but there's no clear flat surface here. There's different protrusions. Let's just try flipping it right upside down. We'll see what happens. I meant to get the cabinet out of here. I'll do that next. Set this down safely, okay. Cabinet, can you come out? Let's get this out of here. It's a beautiful cabinet. It's in really, really good condition. Okay. Oh! Peanut thought I was going to let him out, so... Hey, Peanut! Oh, that's not Peanut. That's Shadow. Peanut! Peanut, where are you? He's probably on the stairs waiting for me. Beautiful sunny day, very cool outside though. It was 9 degrees this morning when I got up here. I'd like to deny that fall is coming. It's a little tough. It's that cold. Okay, so first surprise. A lot of relatively modern parts in here. In a North American radio, this vintage, you would find a lot of capacitors that were, well, there is a lot in here. I'm speaking too soon. One here, one here. There's a bundle. A bundle. What is that? A bundle. A bundle. There he is. Bundle of capacitors. But these are high quality parts. Yes, sirree. So inside this metal box is all the coils and whatnot for, I was going to say for the short wave band, but it can't be. There's no short wave band. This is the rectifier here, this large tube, which we will be checking to see if it's getting hot. Some molded capacitors here and there. There's quite a few. There's one here. They all look to be in great shape though. What's happened to that? I have a cat staring me down here. This is discolored a little bit in the middle, but doesn't look bad. I think if this were really overheated, the whole thing would be darkened. I don't think that's an issue. I don't think that's heat darkening. I think that's chemistry. Some materials flowing between things. Like this tape has absorbed something from inside, and maybe even as a gas or vapor or a long period of time it's collected it in here. I like to make all this stuff up. Makes me think I know what I'm doing. Hey, that's important. If you have the feeling you don't know what you're doing, you're not going to do anything. So you have to continually fool yourself into thinking you know what you're doing. Now, Peanut was just staring at me. Yes? Yeah, I know. You want to go back out? Okay, let's go out. Let's go outside. Break time has come. Well, I think a little more about this radio, just because maybe I'm going to start it up in here today. Come on, Peanut, let's go. Okay, 2 happy cats outside. The temperature is up to 12 now outside, but the sun is hot, so that compensates. Let's just look around here and see if anything looks like it's been on fire or just overheated. Yeah, this kind of capacitor here is not terribly reliable. Funny how come the guy in the middle, the blue one, was a different style? Like, why would they do that? I ask a lot of questions. Sometimes when I'm doing this, watching my videos, I'll make a statement or ask a question, and at the same time I'm saying to myself, it really doesn't matter, it really doesn't matter. So you'll hear me raise questions that I never return to answer. Like, look at that capacitor down there. See the black stuff coming out? Yeah, that is coming out. That black stuff is coming out of that capacitor. I think it's better off inside the capacitor than outside. Can you see also there's quite a dust covering on that capacitor? That may is a big word here, indicate it's a high voltage capacitor, or it's involved with the high voltage side of things. What's the voltage rating on it? 250, not that high. And there's that unusual thing there. What is that? Well, it looks like a wire wound resistor. Like, this is a wire wound resistor right here. That looks like one too. Did it melt off everything inside? Is that what happened? Like this one's got a black covering all the way down it with the company's writing and logo on it. This one, the middle is exposed. It looks like that's the way it's supposed to be. Okay, just trying to identify anything that is cooked, overheated, is obviously in the throes, in some kind of death spiral. This is made with very good parts. The other thing about this radio, these parts are spread out. Like there's a lot of space in here. A lot of these European radios, there are parts under parts under parts. And this part here, this is the push button switch assembly, I guess you could call it. So all those switches have a lot of terminals coming up. There's a set there, terminals, a set here, a set here. Every switch has a set of terminals, and the radio designers utilize these terminals as a good place to hook up all kinds of parts. So this is often a very busy place in these European style radios. Again, this one's spread out. You can pretty much get at everything. There's coils with some fine wires that you do not want to break. There's another one of those blue capacitors. I wonder what's special about them. It's got a resistor strapped right in parallel with it. It could be these are better capacitors, they're more precise, they're plus or minus 5% instead of 10 or something like that. Everything looks great. In fact, this looks like a radio that was not played an awful lot, but can't be sure about that. This was made, let's guess this was made in 1950. That's probably a reasonable guess. 1950, so that's 50, 60, this is 72 years old. Holy smokes. Yeah, that's old. 72. Just so you know, 65 is young. But 72, holy smokes. Okay, I think I'm going to get this guy ready. We're going to try playing it, because there's no reason not to. It all appears to be in pretty good condition. Okay, get that all set up, and we're going to hear this guy. Well, maybe we'll hear it. We'll hear something. What's going on? One of the things I try to do when I'm fixing radios is get them working as soon as possible with as little work as possible, and working to any degree. So if you tap the antenna, you can hear something coming out of the speaker. Until they're operating to that degree, to me, it's very risky to work on the radio. Because you could make a mistake, and if the radio's not operating, you can't test the radio to discover your mistake. So you could make a mistake, put a part in wrong, maybe put 2 parts in wrong, oh my god, maybe put 3 in wrong, while you're trying to get the radio to work to some degree. So I'm always trying to run these things pretty early in the affair, including right at the very start like this. So that's the idea. Now I'm not going to plug this in the wall and flip it on. I have ways of controlling the amount of power that will come to the radio. So if there's something seriously wrong, like a short circuit in the power transformer, I won't blow it up finding out there's something wrong with it. I'll know right away. And the simple system I use is called the dim bulb system. System being pretty generous. So what happens is the power I'm going to plug into this guy here. This guy is going to receive his power through these light bulbs, not along with, but actually through the light bulb filament. So if this thing draws a lot of power, the lot of power coming through these light bulbs will cause them to come on. At the same time, a lot of voltage will drop on those light bulbs, and the amount of voltage reaching the radio will be greatly reduced from what it could be. This is a moderate size radio. I think I have both lights in. Yeah. So those 2 lights are in parallel. So there's 2 paths for the current to flow to get to the radio. My expectation is when I turn the power on, or when I turn the radio on with power to it, these lights will come on bright and then quickly dim down, maybe down to the point where you can't even see them, and then come up again a little bit. at the same time, we should start, as it's coming up, we should start hearing the radio operate. That's sort of a very initial test, if you like, of the functioning of the radio. What we could hear, and again, I can't remember what I was told about the radio. It could be I was told it just stopped working. I don't know. I don't have the magic eye in, but that doesn't matter. It's inconsequential to operating the radio. So I'm going to plug in here. Now another thing, this cord, if you trace it all the way back in my shop, you'd arrive at an isolation transformer. And what that does is it means there's very, very little possibility of getting a shock from the radio while it's operating through me into the ground that I'm standing on. I mean, there's a very low probability of that anyway, because I wear rubber-soled shoes. I'm standing on a rubber-backed mat. The mat is on top of a concrete floor, which is covered in floor tiles. It's pretty hard to get a shock through all of that. It's not hard to get a shock between your hands. So if maybe I had a tool and I didn't know it, I'm touching the shank, and I don't know it, I've touched something live in here, and then I reach with my hand and I touch this, or anything in my shop, everything is grounded here. Under normal circumstances, I would get quite a lift. But because I'm feeding power through the isolation transformer, there is no circuit. There is no circuit except a very minor capacitive circuit. So nothing that's going to kill you, that's for sure. So that's what's going on here for safety. If you are doing this kind of work on your own and alike, all I can say to you is your safety is your responsibility. How you deal with it in your shop environment, that's your responsibility. Don't mimic what I'm doing thinking, oh, now that'll be safe. It's not like that. You need to understand what's happening. And if you were to go back years and years in my videos, you will see me learn some tough lessons in here about that kind of stuff. So, okay, but I'm still alive. And now we're ready. So I'm going to flip the power on. It's going to go through the light bulbs and over to here. This is, remember the switch here was, oh, it seems happy now. This is the one I was pushing, and then it would pop off on its own. So that turns it off. Every other switch turns it on. So with it switched off, we will apply power in the hopes of seeing nothing happen. Those lights should not light. This guy here should come on and show us the line voltage. Here we go. 118 volts. This voltage here is not actually the line voltage. I have another protective device or control device in here, which is this guy. And I can ramp the voltage up and down and do various things with this outlet using that guy. But normally he just sits there. So the 118 is really coming because of this knob. 118 is perfect. When I turn this on, this number will drop dramatically. And here we go. So we're going to turn it on with the AM radio side of things. And the lights will pop on. Everything should happen. Here we go. Lights are on, going down. So 71 volts, 85 volts, 89 volts. See, heaters heat up in the tubes. They draw less and less power. Now, at any time, we should hear something. These should come brighter again. Okay, they're brightening up now. Supply voltage 95, that should be enough to make the radio operate. Anybody hear anything? I don't hear anything. Okay, something wrong with what I did? Did I hook up the speaker wires all wrong? Well, I don't think so. Is there any sound in the speaker at all? I'm going to disconnect one speaker and rub it. Don't hear a thing. No clicking, no popping. What about this other one? Nothing. There's no hiss. Let's turn it right up. Oh, I hear a hum. Okay, we got something happening. Oh right, we can't tune this radio because it's kind of stuck. It's all the way over to here. I think it's stuck because this may be stuck. I have a better chance to try to break that thing free now. Let's try that. It has nothing to do with what's happening with the radio right now. She's as solid as a rock. Oh boy. So there's a chance that this radio is not going to ever be fixed. This may be unrepairable right away. That might be the situation here. So as I said before, this is the top of the list. It really makes even turning on the radio kind of a waste of time because unless that capacitor moves, the radio can never be used again. Let's try another band, FM band. Now there's no antenna. Okay, so I can hear a slight hiss. Yeah, we can't tune it again. If you look in the tuning capacitor, what's that little bump, bump, bump? What's that? What's going on there? Is that from the camera? Can't be from the camera. It's got to be a coincidence. Hello, somebody here? That's coming out of the speaker. What is that? Now, why did I pick the camera? Oh yeah, I was going to look at the tuning capacitor. You see there's like a section here with a lot of plates, a section here with a lot of plates, and then there's a sections here with just a couple bigger plates, heavier duty plates. This is the FM tuning side, and this is the long wave and AM radio tuning side. That means there isn't a second tuning capacitor inside this box for FM. Both the AM and FM is all dependent upon this capacitor moving. So we tried medium wave, might as well click it into long wave, but I don't. Oh, you know what? You know what? My phone is ringing.
Yesterday in regards to the radios?
Yeah.
Yeah, so I spoke with my boss and he wants me to connect you with point of contact for this in regards to this situation, just so you and him can connect to see if this would be the right, I guess the right job for you and to get more information.
Yeah, sure.
I wanted to know, do you prefer if I do an intro email and then I'll just leave it for you both to connect and talk? Is that okay?
That's fine by me. I'm a very easygoing guy here, so
Okay.
it's just is he going to write to me first after your introduction?
Sorry, I didn't hear you.
Is he going to write to me first after the introduction?
No, I'm gonna send the email. I'll CC you on it with some introductions, and then he'll be the person that would connect with you.
Very good.
Perfect.
I'm looking forward to it.
Okay.
Okay.
I'm sure you are. Hopefully,
Okay.
I'll meet you one day. Okay. Bye.
Okay, bye. Okay. Okay, that call was from a potential customer who has 60 radios that need work. Holy smokes, 60 radios. Who's got 60 radios? What am I going to do about that? So we were just getting the long wave here, apparently picking up interference. So now we've had no antennas on this radio, so they're really kind of a bad test. And I'm also running at partial voltage. Let's raise it up a little bit. I want to keep these lights in the circuit in case something happens. The lights act a little like a fuse in a way. Let's raise it from 91, get it up around, a little over 100. 104. Okay, so I'm trying to reduce the chance that the low voltage is causing problems. I'm sure that's not the case though. Can't tune it, so we don't know what would happen. FM, and I'm going to use my finger as an antenna. Finger as an antenna. antenna. Which one is the FM one? Well, we'll know when I touch it. Nothing at all. Okay, and if we go to, say, medium wave now, is there a lot of these radios have a built-in AM antenna, loop antenna. There's none here. So this would be dependent on a wire. This really nice radio, and they've left it dependent on a wire. Okay, let's touch these different antenna inputs. Look at that. There we are. And again, can't tune it, but it's working. You know, now when I think about it, I'm pretty sure the owner mentioned this stuck pointer problem. I think this radio may all just work if I can just get the capacitor to go. And nothing more than that. Okay, that's the action. The action is get that capacitor moving. Okay, I think that's enough for today. Tomorrow we'll focus on the capacitor, try to loosen it up. You know, I should continue. I should continue because I need to put in penetrating oil and stuff like that. And it takes time. So, okay, I'm going to keep going. We'll keep going. Let's take a good close look at the capacitor for good places to dribble in some oil. So usually these things get into trouble because of a shaft passing through a sleeve. And that's what we're looking at right now. See this metal here, this is probably cast, maybe a cast metal shape. Can you see it crumbling a little bit? There's heavy corrosion on it. So you see that same metal forms a sleeve just down there, and there's a shaft. In this thing has a shaft passing through the sleeve and appearing over here. That sleeve is probably what has frozen this whole thing. So applying a lot of pressure is actually a good way to try to break these things free. Oil, solvent. This has an anti-backlash gearing system here. I can push on that hard. I'm gonna break my fingernail. Didn't move a bit. Hard. Oh, it won't move at all. Wow. Okay, that's bad. That's very, very bad. It's very, very bad. Because it's one thing if it's dried up lubrication. You know, you can usually push past that. The lubrication is not, even though I call it glubrication once it gets dry, it's not that good glue. In a sleeve and shaft, yeah, it would hang on pretty tight, but you can usually push it past it. This thing is locked solid. That suggests the second problem, which is that corrosion has taken place. There's probably a mixed metal situation in there. The shaft is probably one metal, and this is definitely a different kind of metal here. And the combination sitting in there may have promoted a little bit of corrosion. Now obviously you can apply pressure to these parts, and there's a point where it's too much and something breaks. So we don't want to get there. Heat is also helpful in the case of the lubrication problem. Not so helpful in the case of the corrosion problem. There's a bearing at the back there. There's a screw that adjusts its pressure and also affects the position of these plates, which have to mesh, right? They have to mesh with these other plates down in here. Sorry, I'm holding the camera funny, so I can't control it as well as I should. What are we going to do here? Well, we would start with the least dangerous stuff. Well, that would be probably alcohol, or WD-40 is actually pretty good. WD-40 is a combination of a volatile solvent and oil. Some carefully selected secret oils. Maybe it's fish oil, who knows. And the solvent part, though, is useful. I guess I just spray it up in there. can. Looks like I would just shoot some up in there. What can go wrong? Getting oil on the strings and stuff. You don't want to get oil on the strings. But probably not the end of the world, because these strings are probably terminated on the wheel here, so they really can't slip. And I call it a string, but this is a wire. Yeah, we have that other string. The other string may have gone the way it went because of the problem with this tuning capacitor. You can see the other, so I'm looking at the left edge now of the sleeve. You can see it looks like a washer and then a gear. Right in there I've got to put some oil. I'm use WD-40 because it has the red pipe. Get right up in there. Likewise on the other side, just past the edge of the sleeve, a dousing will help. Okay, time to douse. Douse. That sounds like an old English word, doesn't it? I do douse thee. Okay, water displacement formula number 40. Well, I'll tell you what, you stand here, and I'll stand over here. This won't work either. You have to keep the can upright. Right at the edge of the sleeve there. You know, these are stupid, right, these cans? You push this top and the red pointer wanders around. These are stupid. Or people who buy this stuff is stupid people. Come on. Oh, there we go. Okay, and then down in this one too. So the magic in getting fluids like this to travel up in this sleeve situation, and I missed it. I missed the sleeve. Here it is over here. Is to get the thing moving. As soon as it moves, even the tiniest amount, penetration greatly increased. So we're going to apply even more force to it. I'm going to use leverage here. So if I lever this, if I'm reckless, I'll put too much power into it. This is powerful levering. Power. Not with this screwdriver, it's not. A finer point here. I'm just going to try to grab the gears and give it a push. Oh, there it goes. Okay, so the slightest movement is a big thumbs up. A big thumbs up on that. I think I had my hand in the way so you couldn't see it, but I can do it back this way. Oh, don't break the teeth. Don't want to go that way. Okay. I'm here to accommodate. There it goes. I can see the tuning knobs turning. You can't see a thing but the end of a screwdriver. Let's try it like this then. Okay, let's move it a little further. Doesn't want to go. How come? Let's give it some help. No, there's not much help in this. Well, it moved a little bit and now it's jammed up. Let's try moving it back again. Oh boy. I mean, so that's about an inch, and this is about, I don't know, 8 or 10 inches. So that's a times 10 power. Pushing down on this with a lot of power too. You got to be careful here. Sounds like an old creaky boat. There we go. There we go. It's good to go just back and forth. Ooh! Okay, so that's probably enough for now. give it a little extra WD-40. Now I could have used alcohol. I often use alcohol in these situations, but I like the idea of the lubrication going right in. And I think, alcohol is not really intended for this kind of thing. And what if I've assessed it wrong and it's actually the main capacitor bearings? It's really not very likely, but I'm going to dab a little bit on those. 2. Let's give it another move. Get right on the capacitor thing here. Wow. Let's not get on the capacitor thing. Stick with the gears. Wow. You'd think, once it starts moving, it would just get looser and looser, and that usually is what happens. So how do accidents happen? So I don't know the whole story. I'm trained in accident investigation and stuff. I've been so many years I don't remember it all, but you need a combination of 4 factors before you can have an accident. And one of them is energy. You need some form of energy. Any form of energy will do. So I'm pushing here. As soon as I'm pushing, I'm thinking about these things. I'm thinking, high pressure, high energy, if something slips, kapowie. So I didn't really explain what happened there. When the screwdriver slipped, I jammed this plate into the other plate. So I just bent it back out again. It should be okay. We're going to have to let that sit and see what happens as time goes by. So we're going to let it sit. I'll be in here once or twice today to try to move it a little bit. And tomorrow we will see if it can be made workable. I'm hopeful. So thanks a lot for watching, and keep hope alive for this radio.